So the second part of Notes 2, so it's not really day 2 because now we're on day 3. Let's back up a little bit. Here's our limits process. Step 1 is we try substitution. If we get a good answer, then great. We like that. That's our preferable way to go. But if we get 0 over 0, it's usually what we get, then we have to try one of the tricks. So the first trick we did was yesterday. That was factoring. 2 more tricks today. One is simplifying a fraction. And the second one for today is, let's see how we want to phrase that one, is multiplying by a conjugate. Multiply by a conjugate. So that's the big picture on limits. We did the first couple of things on Tuesday. We'll pick up the next 2 tricks today. So try to get the overview of where we're going, where we're headed, what we're doing. Now we'll dive into the details of fractions and conjugates. Like I said earlier, the concept today is not really that difficult. The process of simplifying these with your algebra is what is going to mess some people up. So if your algebra skills are good, today is easy. Maybe I should phrase that differently. That's the true statement. Today's difficulty is directly correlated with your algebra ability. There we go. Use a math word. So we'll find out. This is a great test of your algebra skills. All right, so number A. If we plug in 5, because we always want to start with substitution, because sometimes we get a quick and easy answer and we're done. So you always got to start there to see if it works. Let's see, 5 over 5. Oh, that's negative 5, sorry. So 5 over negative 5 plus 1, that'd be 0 in the top. And then 5 plus negative 5 in the bottom would be 0 in the bottom. So 0 over 0, that's where we get kicked to our tricks here. The good news about the tricks is it's always very easy to tell which trick to use. So it's never difficult to figure out which trick you should be using. Like you look at all of those on this page, none of those look like they could be factored. None of them have any square roots. So this whole page is simplifying fractions. So the good news is it's easy to tell if you need to use a trick, and it's easy to know which trick to use. So I need to simplify this fraction. Well, I would like to multiply the top and the bottom by whatever it takes to make the fractions go away. So this one's pretty straightforward. What could I multiply by to make all the fractions go away? Well, there's only one fraction to be worried about. So what should I multiply by? X. So I'll multiply top and bottom by x. And we'll see what happens. So I'll distribute the x to both pieces. What happens when I multiply 5 over x times x? Gets rid of the x's. That was the whole point of multiplying by x. So the top becomes 5 plus x. And the bottom, it is 5x plus x squared, but look what's in the, let's just leave it because we would like for the 5 plus x to cancel. So limit as x approaches negative 5. We can cancel the 5 plus x's. I don't remember if it was your class or the other class. What happens if we cancel everything in the top? What's left in the top now? 1. Good. It's not nothing. It's not 0. There's a 1 there. So we now substitute -5, and we get -1/5. Again, the concept is clear out the fractions. The difficulty is, do you know what to multiply by, and can you cancel accordingly? Letter B. So if I plug in 2, I get 1/2 minus 1/2 over 2 minus 2. So sure enough, 0 over 0. All of these are going to turn into 0 over 0, but we have to check because once in a while you get an easy one. All right, what should I multiply all of this by to make, this time I got 2 fractions. What should I multiply? What would cancel both an x and a 2? 2x. So I'm going to multiply the top and the bottom by 2x. So in the top, 2x times 1 over x, the x's cancel. 2x over 2, the 2's cancel. And then in the bottom, I'm sensing a pattern here. I think I want to leave it. I don't want to distribute the 2x because what can we do now? Do that. Cross them out. Reduce. Yes, as long as you include one other thing. What does it reduce to? -1. Because it's a subtraction with the order reversed. So I need a -1 in there. So now let's try x equals 2, -1/4.
We're solving on the test. Do we need to put the limit and then x goes to 2 on that part of the steps?
Yes, let's say yes. I need you to show that. All right, C. Things get a little bit more difficult here. What do I need to multiply everybody by on this one?
X plus 1, x plus 2.
Right, x plus 1 and x plus 2. So this one's going to be a little trickier. On the first term, the x plus 2's cancel. That would leave 5 times x plus 1. On the second term, the x plus 1's cancel. So that leaves 4 times x plus 2. And in the bottom, I think I've learned my lesson to just leave it all multiplied out, and we'll hope that something cancels here in a minute. Oh, you know what I didn't do to start this problem? I didn't verify that it was 0 over 0. Like I was pretty sure it was going to be that way. 5 over 5 is 1. 4 over 4 is 1. 1 minus 1 is 0. 3 minus 3 is 0. So yes, it's 0 over 0. All right, what do you think we need to do with the top? All right, there's nothing to cancel. Please do not cancel these x plus 2's or these x plus 1's. No, do not do that.
You have to distribute.
Let's distribute, clean everything up, and then we'll look and see if something will cancel. So 5x plus 5 minus 4x minus 8. I'm not going to even rewrite the denominator because I'm working on the numerator right now. So the numerator sort of cleans up to x minus 3. Is that good news that it cleans up to x minus 3?
Yes.
Yes. Why yes? Because there's an x minus 3 in the bottom. So now we can cancel something. X minus 3's go away. Now I can just plug it in. So 3 plus 1 is 4. 3 plus 2 is 5. So 1/20th. Again, if your algebra skills are good, this isn't too bad. Letter D, what should we multiply by for that one to make everything go away? X plus 1 and x plus 2. I'm going to press pause.
Should we just
Oh, we're supposed to check it's 0. 2 over 2 minus 3 over 3, so that's 1 minus 1 over 1 minus 1. So yeah, that's 0 over 0. So I'm going to press pause. You see if you can take it from there.
we have to keep going, or is it a D?
What? I haven't done anything wrong, but it doesn't look like anything cancels.
Change the -1 thing.
So the -1 thing, a couple ways to do this. I could just flip this around as 1 minus x, and then they cancel the -1. If you'd rather, you could factor out a negative, and that would leave you with x minus 1. And then they more straightforward cancel, but you've already handled the negative thing. Ty?
So when you do on the second row, 2x, or, yeah, to the left of that, it's 2 times x plus 2 and negative 3 times x plus 1. How do you know which place to put each one? Like, how do you know it's not 2 times x plus 1?
Because when I multiply, so I didn't show all my steps here. I'm going to multiply 2 over x plus 1 by x plus 1 and x plus 2. So the x plus 1's cancel. And then I multiply 3, minus, over x plus 2 times x plus 1 and x plus 2. And the x plus 2's cancel. I just don't usually show that step. I just look and see what cancels and write what's left. So not quite done with this problem, but almost there. Just plug in a 1 to what's left. 1 plus 1 and 1 plus 2, so that would be -1/6. Algebra, 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 algebra. What do you think you should multiply top and bottom by on E?
Probably
2x. So see if you can take that one from there. Well, what's 10 minus 10 equal to? 0. So there's nothing to cancel. Yes. And if I plug in 5, let's see. I get 0 over 0 times 2, which is 0 over 0. And so I'm still kind of stuck on this one. Don't like that answer. So we're going to go D and E because we used our trick,
but the trick goes.
but it didn't help. We still got the 0 over 0. Gosh, it's not really D and E, but I don't like the explanation. You know what? Let's back up a second. Let's explain and talk about this one. The top is 0. Like, not close to 0, but definite 0. In fact, let's back off of this.
Wouldn't the 2 be a 10?
Yeah.
Because there's a 2x.
2x.
Did I mess something up?
So it would be
It's still
0 times 10,
effective thing.
not 0 times
Still 0.
Oh, yeah, 0 times 10. You're right. But that's still a problem. So the top is definitely 0. The bottom, like when we say x approaches 5, that means we're getting really, 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 really close to 5. So 0 divided by like 5.00001 minus 5 times 2 times 5. This is a tricky one. It's like the top is a hard, definite 0. 10 minus 10 is 0. The bottom is like, well, it's close to 0. So 0 divided by
Just put about D.
anything close to 0, but it's not about D and E. It's the top is a definite 0. So it's 0 divided by almost 0. So the answer is 0. Because this wasn't close to 0 over close to 0. It was like 10 minus 10 is definitely 0, regardless of what this limit is. The bottom is like getting really close to 0, but it doesn't really matter if the top is almost want to say a hard 0. Not a close to 0, but a definite, hard, unchanging, absolute, not absolute 0 like temperature, but like it's a 0, not almost 0. The bottom is almost 0. Yeah. This is where people don't like limits, because like, what do you mean almost 0 versus 0? Do you see the difference between the top is definitely 0. 10 minus 10, that's 0. The bottom is, if I plug in something close to 5, I'm going to get something close to 0. But there's a difference between actual 0 and close to 0.
So then,
This is probably the worst one on the page.
the only way to get an actual 0 is if there's no x's. So
Yes. If there's no x's involved, then you're definitely getting a 0.
We're square. Done. It's all done.
All done? We're
All
good.
done. So when you look in your roster, he should show up.
Thank you.
You're welcome.
She's amazing, by the way. Miss Boney. She's our AP person. Takes care of us. F. F does not work out with the 0 business. F's a little bit easier. F looks backwards than the others. But what do you think we should multiply by? X plus 2 and 9 minus x. And it looks like we should leave the top factored on this one. And then worry about cleanup on the bottom. So the x plus 2's cancel. That leaves 4 times 9 minus x. The 9 minus x's cancel. That leaves negative 7 times x plus 2. So I like the top because it's already factored. I hope something will cancel. I need to clean up the bottom and hope something will cancel out of that. So top stays the same. I'm not even going to rewrite it because I'm worried about the bottom right now. 36 minus 4x minus 7x minus 14. So that would be negative 11x plus 22. So how can I further factor the bottom? What could I take out of negative 11x plus 22? Negative 11. And that would leave x minus 2, which is good news because I look in the top and there's an x minus 2 sitting there. Now, Tyler asked earlier about writing limit. Like, officially, you're supposed to write it every time, but unofficially, no one wants to write it every time. So you kind of just write it out here once, and we all know that you mean it goes to everything. Or the limit really should be written on all of them.
X minus 2.
So let's see.
Negative 11 times the x minus 2 on the bottom. Negative 2.
Negative 11 times x minus 2 on the bottom. But the x minus 2 is canceled because there was an x minus 2 in the top. And then 9 minus 2. So 4 times 7 over negative 11. 28 over negative 11. Fractions, fractions, fractions. A little word of warning. In calculus, you must know how to manipulate various expressions like this. You just took a practice AP test in calculus, and I'd say the average person missed or probably lost about 3 questions per person. They were each worth 4 points each. So like basically a letter grade. They lost a letter grade because they did the calculus right and then they messed up some sort of algebra. And so it's so frustrating in calculus where, hey, you could be making a B if you knew how to do algebra. You could be making an A if you knew how to do algebra. And that's why we try to get your algebra skills where they need to be, because we can teach you the calculus, but if your algebra background is weak, then you're just going to be fighting an uphill battle all year long next year. So I guess you've already made your course selection, but you can change it if you need to. All right, so that was trick number 2, and number 1 for today, but number 2 overall. So factor, simplify fractions, and the last one is multiply by a conjugate. You remember what a conjugate is? Conjugate kind of fixes square roots. So what do you think the conjugate is of this first one? Okay, it's a good question, because a conjugate of what? Like, you could argue that it's x plus 16, or you could argue that it's square root of x plus 4. Let's see. If a square root's involved, multiply by a conjugate of the term with the square root. So yes, x plus 16 is the conjugate of the bottom, but we want to multiply by the conjugate of the square root term. So square root of x plus 4 on top and bottom. So I've got what looks like 2 FOIL problems. See what I mean in a minute. Let's FOIL the top. What's the square root of x times the square root of x? X. What's the outside and inside when I multiply by a conjugate? Every time. This is why we multiply by a conjugate. They cancel. Every time. That's why we multiply by a conjugate. So the O and the I of FOIL cancels out. And then negative 4 times positive 4 is minus 16. Yes, let's leave the bottom as is. Let's not FOIL the bottom. Why do you say that? Because you can cross out the x minus 16s now. You get these are all sort of rigged problems to work out like this. I don't have to fix the bottom. What I want to do now is substitute and see if it works. So I don't need to fix the bottom, I need to substitute and see if it works. So square root of 16 is 4. 4 plus 4 is 8. So the answer is 1/8. Oh, once again, I forgot to check to make sure it was 0 over 0 to begin with.
It does do that.
But it was. Tyler, what was your question?
Wouldn't you have to do plus or minus 4?
Plus or minus only happens if you put the square roots on an equation. If the square root's already there, then it's not plus or minus. Right? That's the whole, what's the square root of 9 equal to? Just 3. Separate question, if x squared equals 9, then x could be plus or minus 3. So if the plus or minus is there, you just use the positive. If you put it on because you're solving an equation, that's when the 2 of them show up. The plus or minus thing. Yeah. All right, what's the conjugate of... Well, first of all, do we want the conjugate of the top or the conjugate of the bottom? The bottom. So which sign do you think we change? Yeah, leave the square root thing alone. That way when we multiply them together, it'll just become x minus 1. But do change that middle sign to plus 2. Again, it looks like two FOIL problems. Which do you think we should FOIL first, the top or the bottom? The bottom. Always do the one you're trying to fix, do it first, and it should cancel something in the top. So let's leave the top alone for now. Let's FOIL the bottom. So I'm leaving the top alone. I'm hoping I don't have to FOIL it because that looks ugly. The bottom looks ugly as well, but what's the square root of x minus 1 times the square root of x minus 1? X minus 1. How about the O and the I of FOIL? Cancel each other out. Negative 2 times plus 2. Negative 4. So the bottom is x minus 5. Will that cancel something in the top?
Yes, you can do that.
Yeah, well, I'd rather you say sort of. Right? If you cancel it, I'm fine with that, but what does it cancel to? Maybe that's the question to ask. Negative 1. It doesn't just cancel. It's a subtraction in the order switch, so I need to put a negative 1 up there. All right, now let's try plugging in 5 again. Let's see, square root of 4 is 2. 2 plus 2 is 4. Stick the negative on there. Negative 4. Again, the concept isn't bad, but how are your algebra skills? All right, C, there's not a square root in there, but it's still under this conjugate section. So, well, let's once in a while remember to check plugging in 0. What's the cosine of 0? 1. And the sine of 0 is 0. So yeah, we get 0 over 0. So we got to do something. We are going to use, there is sine squared plus cosine squared is 1. We're going to use that in a minute. But not yet. There's only one thing I could even possibly take a conjugate of. The top or the bottom? The top. So let's multiply the top and the bottom by cosine of x plus 1. So we're foiling the top. We're going to leave the bottom alone, right? Whichever the conjugate is, that's the one we multiply first, and then we leave the other one alone and hope something works out. Cosine squared x. The O and the I of FOIL always cancel out. Minus 1 over sine of x times cosine of x plus 1. Huh. Crud. Nothing cancels, right? Sort of.
The cosine squared cosine squared x equals.
So long ago we said that sine squared plus cosine squared equals 1. That's a common enough trig identity. You gotta have that one at the front of your brain because we use it so often. So what does cosine squared minus 1 equal? If I move things around, careful. Your algebra has to be careful here. Cosine squared minus 1 would equal negative sine squared. So I'm going to replace the top with negative sine squared of x. can we reduce now? Yeah, one of the signs will cancel. So negative sine of x over cosine of x plus 1. All right, we've cleaned it up as much as we can. Let's substitute in again and see what happens. Sine of 0. That would be 0. Uh-oh, I'm getting worried. Got a 0 in the top. What's the cosine of 0? 1. 1 plus 1 is 2. 0 over 2. That's okay. That's 0. We're okay with that answer. What do you think we should multiply the top and bottom of D by? Mm-hmm. 1 plus cosine of x. So we'll pause and see if you can take that one from there. And then if we plug in 0, see 1 plus 1 is 2. Sine of 0 is 0. Uh-oh, if we have a 0 in the bottom, that's a DNE. We can't handle that. We're not going to do F. Let's try E, and then we'll be done. What should we multiply by?
The x plus 2 in the square root plus.
Yeah, the conjugate of the top. And again, the conjugate is the one that you actually want to multiply first in hopes that it will cancel with something from the bottom. And it looks like an awful factoring or an awful FOIL problem, but because all the square roots are like the same square roots, it kind of works out. So, do we know what the square root of 2 plus the square root of 2 is?
Square root. So it's 2. It's 2 root.
It is 2 square roots of 2. And we're going to start to be, since we have kind of switched into calculus mode, in calculus you get to leave answers with square roots on the bottom. You don't have to fix them in calculus.
But this isn't calculus.
So, well, the course isn't calculus, but this topic is calculus. So you can leave it alone, or if it really bothers you, you can fix it. Square root of 2 over 4. We would accept either answer. It'd be fine. Again, here's sort of the summary, but I would kind of rephrase this. Try substitution first, always. And if it doesn't work, then you get to use one of the tricks. Factoring, conjugate, or fractions. Alright, so today's assignment is the back half of worksheet 2, 10 through 18. So again, Tuesday's assignment was worksheet 2, 1 through 9. Thursday's assignment is worksheet 2, 10 through 18. Answers are posted. If your algebra skills are where they're supposed to be, you can definitely finish this before you leave.